First off, they've given me the handheld mic because a lapel will tend to rub on the beard a bit too much and give folks all kinds of noise that you don't actually want to hear. So you'll have to suffer through me sitting up here like Dick Clark with a big microphone. Prakash gets to be a little bit more relaxed here. So just to give you a little bit of background, I'm Redbeard from CoreOS. I do many, many different things, including over the course of the past year. I've done a lot of work with Prakash here, which is kind of how we first became acquainted. And through the things that we've done at data.com, we realized that there was some stories that folks would actually be interested in hearing, and just outstanding questions that we have worked out together that talking through this a little bit would give more insight into the community as a whole. So I guess to start, Prakash, can you just give us an introduction of yourself?
Yes, I work as a sysadmin at data.com. I started about 8 years ago. I started when the company was relatively small, and over the years we have grown, and I'm responsible for infrastructure, automation part of it, provisioning automation, monitoring automation, and we actually deliver deployment automation, code is delivered to production as RPMs, and then we started using Dockers, where we started migrating towards using Dockers as a delivery to deployments.
So I guess just to give folks a little bit more background, can you explain what it is that the service that data.com provides?
Yeah, data.com provides business contact information. We are comparable to LinkedIn. So we sell business contact information, but we use crowdsourcing as a means to get the business contact information. And we integrate with Salesforce CRM through API. So we manage the contact information of the CRM customers through our APIs, clean API, search API. And industry believes that we have up-to-date contact information. So
as a service that integrates with Salesforce directly via APIs, it strikes me that there's going to be a lot of service-to-service communications going on. Kind of asking about that, was that one of the reasons why CoreOS first, or containerization in CoreOS first caught your eye?
So I think, like I said, we were already treating our servers as cattle, and deliveries were code was delivered as RPM, deployments were done, infrastructure as a code was in place. So this was back in 2013 when I went to one of the meetups where RelateIQ presented about how they have converted their development environment into Dockers. Maybe this was October 2013. That's when I first came to heard about Dockers. And then after the meetup, when I met with the guys at RelateIQ, I wanted to also learn how they manage their infrastructure. So when I asked them about how they patch their systems, they said, we just use CoreOS. We don't patch our system, we just use CoreOS. And that was like, I still even don't know much about Dockers. So, and then I hear about this operating system that just runs Dockers. So, and that made me realize that I need to pay a lot of attention, and then I went back, started learning about namespaces and C groups. This was the time when even like people were using LXC to run containers. Docker was pre 1.0, Docker version 0.7 was running at that time. And this was the first time I heard about CoreOS, but we still didn't use CoreOS, but then we started converting our applications into Dockers. and Docker had like device mapper issues, Docker daemon crashing, and things like that were some of the issues we had. And we wanted somebody that could support the latest kernel and latest Docker versions. So with that intention, we have approached you guys to help us with containerizing and also to get the support that we needed.
Yeah. So in the course of the past year, we've talked a lot about the steps that we were actually going to have to take to build containers. We've walked through different regulatory challenges that had to be taken into account. Can you tell us a little bit more about what the actual development life cycle looks like when you work with both building application containers and then deploying them onto CoreOS?
So one of the first things that you do when you migrate from your applications to containers is that you focus on using a base operating system. Because of security reasons, we had to develop our own base operating system that we could use our applications to deploy on. So we started with the base operating system and then converted all our applications into a standard base images.
Okay. So as far as curating the actual base images themselves, did you have any specific challenges with both storage of those as well as access control and keeping it inside of the behind the firewall for data,
yes,
for data.com and Salesforce?
Yes. So creating one of the things that we need to make sure is not only download use the operating systems or the base images that are available on Docker registries, but also make sure that we don't push our code into Docker registry. Docker registry by itself doesn't support those things, so we have used a PR that Red Hat has released that will enable us to not push things to Docker registry server. We were doing things like that, and then when we migrated to Quay.io, we also had additional benefits of like searching through the Docker registry. So when we started working with we support 9 different teams. So during the migration process, we first worked with one team. So in the beginning, it was easy that we used to share all the Docker images that were there in the registry through spreadsheet. And as we supported more teams, we through our build pipeline, whenever you commit an image to the Docker registry, we used to also create a dummy RPM package.
Okay.
And so the developers used to search through the Yum repository for the images and then use the image. So we were doing things like that, and then using Quay.io helped us as we started supporting more teams.
Now, in your case, though, you're actually running Quay.io behind the firewall, correct?
Yes.
Okay, so that is just giving you some different opportunities as far as blocking access and making sure that you have tighter access controls around it.
Blocking access, the search capability, and the ability to clean up your Docker registries through the web interface, not through API or some of the things.
Okay. So switching gears a little bit, what are the different deployment types that you're using for CoreOS? Because I know, when we first came in, there was a discussion around OpenStack, but I know that there's been a number of different deployment tools used to build out machines, as well as different types of environments that your developers are running in.
Yes. So we also wanted to use the same operating system from development environment to all the way to the production. So that was all, and we use CF Engine for our change management, and we started migrating our things that we did in change management into the cloud config, or started migrating some of the things into containers that we run into CoreOS. So once we had a good CoreOS image, we started supporting them in OpenStack. So, and we started giving workshops to development teams so that they know how to create a cluster, how to add a CoreOS node to the cluster, how to delete that from the cluster. So once they have the cluster, then they can fire up their like full environments or partial environments on top of this cluster. And
So the team was actually successful, though, in being able to really duplicate the environment both in development all the way through production.
Yes, and not only when you containerize your applications, you like most people know, you can take all your image all the way to the production. So, but it also gives the ability to the teams to fire up environments, to fire up a production environment on an OpenStack. Most of the configuration, if you work on your configuration and to generalize it, so you can fire up a production like environment in your OpenStack itself, and it will reduce some of the deployment issues that happens because of configuration. And the time that developers spend configuring all these different environments has gone down. And then the talk about having a staging environment to catch some issues doesn't happen anymore. So those are some of the things that have helped us.
Great. So I think it's safe to say that CoreOS has a rather opinionated model for how things are done. Did you find that opinionation to be a challenge when you were first bringing CoreOS into the organization?
Yes. So we, like I said before, we wanted to get help from CoreOS because at that time this was, even Docker as a company did not have any professional services help. So to the management, it was the biggest concern was that automatic patching. So CoreOS was not at stable version. It was maybe around beta at the time. So I did not get a buy-in from management to automatically patch things. So core update was also not there at the time. But then patching comes at when you are completely migrated to CoreOS. So we needed to do a lot of work to migrate our applications. So we did not go to production yet, but then we spent a lot of time migrating our applications to containers.
Okay. So, also, how many folks do you actually have administering CoreOS right now? Because I know that if there's a lot of automated processes occurring, that there is the potential to kind of gain some efficiencies on that front.
Yeah, so we have about 3 people that work on CoreOS, not dedicated, but these are the guys who have worked on it. So
they 3 kind of part-time guys poking at it. And how many, just in kind of broad strokes, how many folks do you have working on the other base systems?
So these 3 guys have worked on migrating things to Cloud Init, migrating things to containers. So we used to have Cobbler as to provision our host. So some of that work that was done in provisioning was migrated. But like I said, the workshops that we conduct for people to use CoreOS, so maybe about 50 to 60 developers use CoreOS in their development environments or in OpenStack. But they don't modify cloud init, or they don't.
They just worry about the actual applications and containers themselves.
Yes.
Interesting. As far as the various components of CoreOS, how are you actually using those? Because there's a lot of pieces involved, from Flannel to Fleet to etcd.
Yes. So right now we are using CoreOS and Fleet to create the cluster, and etcd is behind the scenes managing the cluster, but on we have some specific networking requirements. So some teams, when they go through the work to migrate their applications to containers, they have scoped it because some of the configurations, some IP addresses were hard coded in the configuration. So we used Weave networking, so that we create this overlay network on top of Docker host, and with Weave plus power strip, we are back to Docker run commands, and then we are back to using fleetd.
Yep.
So even though some applications that did not have like a lot of development time allocated to it, we were still able to containerize them by using Weave.
Now, through that process, of going through and containerizing all of your applications, do you feel both yourself that it was a success, and what's the relationship been like with other teams? Like, are they looking to you and seeing a degree of success and deciding that that's a path forward?
Yes. So, I mean, the teams. Once you start containerizing, once you see the benefits of productivity, so more teams get the excitement. More teams wants to be on board. They want to learn from each other. So
that's great to hear. Now, I know that community events like this have been pretty important as well. You often show up to the CoreOS meetups and stuff like that. Have you found that like collaborating with the community has also given you more insight into roadmap for the future?
Yes. So I learn few things coming to the meetups, and then I go back to the teams and try to implement them. I take some time to get them implemented, and I come back. Even today, we are using in production, but some of the next challenges would be like to provide visibility into the clusters we have. The troubleshooting, so you can't tell developers, like it's like a banking analogy. So you can put your money in the bank and say that you can't tell people that you don't need to look at your money. You should give them ability to check their bank balance often, or so when you take your containers into a cluster, there should be more visibility and more troubleshooting ability. And there are tools available right now like Mesosphere or fleetd, but they are more scheduling. But I am looking at more things like
NSN
provides
deeper kind of introspection tools.
Yes.
There. Now, did you find that there were any unforeseen challenges when you were going through the process of containerizing applications?
So containerizing, so the deployment wise, in the build pipeline, the stability issues were the main things that we encountered. Migration was relatively easy because we were already delivering code as RPM. So our Docker files initially were all like from and then yum install this, yum install that. It was relatively easy to migrate to Dockers.
Mm-hmm.
And then for a while we were using both RPMs and Docker files as delivery, and then we started migrating from RPMs to Dockers, and any new application is now only is delivered as a Docker file.
Okay. Well, yeah, so that's a good point. Previously, if you were delivering the actual assets of the applications as RPMs, it kind of implies that there's some RPM-based distribution under there. Have you made any changes to the base operating system in containers as well?
So the base operating system is around 125 MB right now. We have not made much changes, but we made it pretty minimal so that anything that the application depends is added as a yum dependency. And one other benefit that happened is that so the patching used to be a coordinated effort before. So when we have to patch these internal environments, we had to coordinate with different teams, come up with a schedule so that we can patch these systems. But now, because the teams own the base OS, so they own all the dependencies that are in the base OS. So if you have to patch an Apache, the teams just deliver a new image.
Okay.
And they are decoupled from the patching that we do on the host, on the clusters host that we have.
So has that given, for example, the security team a higher degree of confidence around both the code base and the security of the systems as well?
Yes. So yeah, even on the base image, we go through the hardening rules that we have. So all the things that we used to apply on the OS before were done on the base OS also.
So you really have, control over the entire life cycle of those applications.
But yeah, container really is just an isolated process. So if you treat it like a VM, like we did initially, things will be complicated. But if it is, as long as you always remember that it is just a process, things will be easier.
Yeah. As far as looking forward to the future, are there specific things that you plan on implementing as changes over the next 12 months?
Yes, like I said, our base OS is bloated right now. I'm looking at using Alpine Linux.
Okay.
They have released small base images. So I will look into how we can start using them as the base image so that our images will be smaller, and then this Docker pull commands and things like that will improve.
Okay. And as far as CoreOS itself, if you could snap your fingers and ask for one feature request there, what do you think it would be?
So when we work with enterprise teams, right? So migrating the system services like LDAP and things like that will be a challenge to convince other teams. So it will be nice if we have an LDAP integration or a federated container that can take care of authentication.
Not the first time I've heard that one.
Yeah.
So in kind of looking at the entire stack that you've put together with this, We've had a lot of components that range all the way from like how it's changed your development life cycle through how it's given you like different types of visibility to various teams, like both the security teams being able to pull down an exact image and see at runtime what would be run at each stage, as all the way out to like just the 3 guys that you've got kind of managing the actual kind of pipeline and production environment that you've got. Do you expect to see like an increase in staffing around that, or do you think that you'll be able to keep managing the workload with the amount of employees that you've got, or the full-time folks on that?
Yes, I think we can manage with the employees we have, and it actually, one other thing that happened is that testing infrastructure also becomes easier when you might start using cloud in it. So yeah, I don't see that it will add that you need to hire more resources to manage things. So as long as you keep, like, when you run everything as containers, and when you use an operating system like CoreOS, where you will be forced to run everything as a container, even the sysadmins will start becoming like developers because they will start delivering things as containers. So some of our logging infrastructure is done through like containers. So backups are done through containers. Cron jobs are done through containers.
So you really haven't found any processes that you would have run on a traditional system that couldn't be run as a container. All the way from like upgrading firmware down to the application containers that folks think of today.
No, we still have a lot of things that needs to be containerized, but we are in the process of migrating. Whenever we see that we can migrate something as a container, we do those things.
Great. Well, Prakash, I have to say thank you so much for giving us your time. It's been wonderful actually talking with you, and I'm sure that anybody else here who has questions for either one of us, feel free to grab us, and we're happy to talk through some of this stuff. So I think at this point, we are just about ready to do lunch upstairs. I am going to hand things back to Kelsey here for a second, and we are thankful to have everybody here today.
Thank you very much.